Thank you everyone for coming this morning. If you're in this room, hopefully you're here to hear about natural climate solutions in Massachusetts. My name is Laura Marx. I'm the Climate Solutions Scientist for the Nature Conservancy in Massachusetts, and I'm very excited to have two co-presenters with me today, Sebastian Gutwein from the Regenerative Design Group and Sara Grady from Mass Audubon. And we'll be talking today about how landowners are using wetlands, farms, and forests to fight climate change. So I've given this talk a lot of times. I always start with this slide, although at one point I had props. I had a little earth and I had like goggles to put on for adaptation. I might bring that back at some point because it was actually really fun. But the point of this slide is to just take a step back for a moment. Think about all the things that are stressing you out in the world, geopolitical problems, social, etc., medical, and recognize that for most of them, we don't know how to solve them. But then we get to climate change, and we do. I'm not saying we are taking all those actions, but it is not an unknown what we need to do to solve climate change. And to oversimplify it, we need to do three things at once. We need to reduce emissions, because it's fossil fuel burning that got us into this mess, and that's a lot of what will get us out. But we also already have too much carbon pollution in the atmosphere, and so in addition to that, we need to remove those emissions at the same time as we're turning off fossil fuels. And climate change is already here, it's not something in the future, so the third thing we need to do at the same time is adapt to emissions. And what Sara and Bosch and I will be talking about today do all three of those, but largely focus on that second two of removing carbon pollution from the atmosphere and adapting to climate change. So natural climate solutions are ways to protect, restore, and better manage forests, farms, grasslands, and wetlands to reduce and/or remove carbon emissions. Many of you may have heard the term nature-based solutions. Nature-based solutions means using nature to solve a problem. Natural climate solutions are a smaller subset of nature-based solutions, where the problem you are solving is the problem of there being too much carbon dioxide in the atmosphere. So in these two photos, in the top photo I have a rain garden. That is using mulch and rocks and some shrubs. It's using nature to solve a problem of having too much water in the wrong place at the wrong time. Then down in the bottom, I have a picture of reforestation. That's a natural climate solution. Again, you're using nature to solve a problem, but you're planting trees which will pull carbon out of the atmosphere and store it in their trunks and soils and roots, and that is an example of a natural climate solution. Because this is a land trust coalition conference, I would be remiss in not pointing out that if you work for or with a land trust, you are working to avoid the loss of lands and waters, and your very mission is a natural climate solution. So it might not be something that you think about every day, but land trusts are constantly doing natural climate solutions in their work. I do not want or need you to read this slide. I asked a colleague the other day, I was like, do we not have icons for this? He's like, I'm sorry, we don't. So I apologize for putting up this page from the Nature Conservancy's Natural Climate Solutions Handbook, but all I want you to get from these next three slides is that there are 21 different strategies or pathways that are natural climate solutions worldwide. And of those, about 16 of them are opportunities right here in Massachusetts. They include avoided forest conversion, which we just talked about as being key to the mission of so many land trusts here today. Climate smart forestry. I'm going to talk about a case study of climate smart forestry in a bit. Forest fire management, things like using controlled burns or other techniques to make sure that when fires do happen, it's not that we want to eliminate them from the landscape, but how can we make sure that we have more frequent low intensity fires and not ones that burn the entire forest and release all that carbon. Planting trees in cities and planting trees everywhere else. When we move over to the water side of things, we have avoiding coastal and freshwater wetland impacts. So not harming or making non-functional the wetlands that we already have. We don't want to be dredging them, building on them, putting too much nutrient pollution into them. And then at the bottom, we have the flip side. Maybe we've already lost that battle, the wetland already is degraded or lost. Are there ways that we can restore coastal or freshwater wetlands? And Sara Grady is going to be telling us a case study about that in a little bit. And then finally, there are a number of natural climate solutions that happen on croplands and soils. Trees and agricultural lands. We often think about agroforestry and silvopasture as something that happens over there, but there are also opportunities for that here in Massachusetts. Nutrient management, being more thoughtful and more efficient in how we apply fertilizers. There's biochar, which is adding charcoal to soils as a soil amendment to add more carbon to them. And then cover crops, reduced or no-till agriculture, planting legumes, all that are ways to do agriculture in ways that add even more, that have even more power to pull carbon out of the atmosphere. And Gutwein is going to talk about a soils carbon-based case study in a little bit. Now, natural climate solutions got really trendy really fast. And much like the term sustainable or green or eco-friendly, to some extent it started to lose its meaning, and people were using it to discuss things that those folks who defined the term and worked really hard to define what natural climate solutions were didn't necessarily agree fell under that definition. I highly recommend this paper. I know it's a scientific journal article, but it's worth a read. Last year, some of my colleagues, including Peter Ellis, put out a paper called The Principles of Natural Climate Solutions that basically said if you're going to call yourself a natural climate solution, you need to follow 3 principles. Natural climate solutions need to be nature-based. They need to be sustainable, and that includes sustaining the production of food and wood and fiber. They need to be additional, so they need to actually reduce and or remove carbon emissions in some real way. We need to be able to say what that is and measure it. And then they need to be equitable. They need to be taking into account everything from informing a landowner so that they're very open about what choices they're making, including what economic consequences there might be for those choices, all the way to things like providing proper safety equipment to loggers. And here I have 2 examples just to drive this point home. In the top photo, this is a sunken log. So I could take a forest in Massachusetts, cut it down, plant fast-growing willows, grow them for a decade, cut them down, and sink them into the ocean. Would that pull carbon from the atmosphere? Yes, it would. And it would be down in the anaerobic parts of the ocean, so it would be secure. It would do all the carbon things that we want it to do. But it has negative consequences on biodiversity and all sorts of other things. And depending on who owned the land and what they thought they were doing, it may also violate the equitable principle here. In contrast, in the bottom photo, I have a picture of some of my colleagues in an agroforestry system in the Dominican Republic. It's working directly with a farmer who's growing cocoa in this case, planting shade trees that are native, so there's a biodiversity benefit. Those trees provide food, so now the farmer has plantains, breadfruit, mangoes, other things additional to their crops. You can go out and measure it. You can put a tape measure around it. Those trees are taller. There's a double canopy instead of single. All across the board, it hits these principles. And so that's an example of something that meets those to be called a natural climate solution. Why is this important? It's not just semantic. At the bottom of this figure, you see that statement, 1/3 of global emissions mitigation through natural climate solutions. So one reason people work so hard to make sure that these are equitable, genuine, real, measurable, is that when done right, around the world, natural climate solutions can provide 1/3 of the emissions reductions and removals that we need to meet the Paris Climate Change Agreement goals. And in the US, that figure is 20%, so still really substantial. Zooming into Massachusetts, Massachusetts has set itself a net zero carbon goal. You cannot reach net zero without natural climate solutions. Again, I want you to notice here that the largest piece of action is reducing fossil fuel use. We cannot tree plant our way out of climate change. But you see all this progress that we're making in decarbonizing the building, electricity, and transportation sections. And then as you get out closer and closer to 2050, at the bottom of this graph, you see that net zero relies on the idea that we have enough natural systems functioning well in Massachusetts that they can absorb about 15% of the residual emissions at the end. Because there are some sectors, it's really hard for me to imagine a zero carbon hospital system, for example. And we don't want to compromise things like medical care. There will be some emissions that we can't eliminate no matter what. And that's where natural climate solutions come in to reach our net zero goals. Throughout this talk, so in a minute, I'm going to head into our case studies, and we wanted to give you a number of things that you could do. And this one's going to sound really insignificant and silly. In about 2017, when natural climate solutions were first sort of starting being published and talked about, we referred to them as the forgotten solution. They weren't discussed at big climate change talks. People didn't think that they were real, right? Addressing climate change didn't really have anything to do with nature in many people's minds. And you would think that we've gotten past that, but there are so many new people working as legislators, town officials, in state agencies, land trusts, et cetera, general members of the public, that it's starting to me to feel a little bit like 2017 again, where we have people kind of casting doubt on this. Is this actually important? Can nature really do anything? Is it meaningful? So having just given you some examples, and we'll give you more in the case studies of ways that you very likely are working on natural climate solutions in your day-to-day, I'm asking you to talk about them a little more, because the fact that we haven't talked about them for a while, I am seeing that impact in the work that I do. And I think it's both important for people to know that these things are important, essential, and real. And also it gives people an element of hope, because the other thing that's happening is people are sort of starting to forget that we know how to solve climate change. They're getting, again, I'm not going to try to sugarcoat the backsliding and other things that are happening, but again, on some fundamental level, we know what we need to do. And I think it's useful for people to be able to see ways that we're addressing climate change, right in their backyard. So there's a role for nearly every acre in Massachusetts. Natural climate solutions can look like planning development more compactly, reducing nutrient runoff to avoid killing coastal wetlands, providing climate-smart forestry in our forests to produce wood while also growing more wood and trees and carbon over time, adding cover crops to fields to restore the soil and store more carbon in what would normally be an off-season. And so the next 3 case studies are going to dive into some of these examples for all of you. But before I do that, I do just want to take a quick moment or two to see if there are any clarifying questions about natural climate solutions before we go into the case studies. I didn't want people to have to hold those till the end. This is good. I'm seeing people without questions and you're not looking confused, so this is great. So with that, I'm going to hand things over to Bosch to talk about his case study.
Hello, I'm Sebastian Gutwein, and can you hear me? Is this better? There we go. Okay. And I work at this worker-owned cooperative here, Regenerative Design Group, and we started in 2009 doing design build stuff, gardens and permaculture and farms, agriculture, things like that. And then as we developed, we got larger and larger and started thinking about bigger and bigger issues. And so now we do everything from statewide planning to a small residential home. In 2019, we started doing this Healthy Soils Action Plan. So we worked on this until we worked on it for a couple of years. We gave it to Baker, Governor Baker, and it sat on their desk until in between Christmas and New Year's. We got a call saying, hey, we want to put this out before we leave office on January 5th. Can you make all these changes? So then it came out, them walking out the door. It's great timing, right? They had it for a year, and then you're like, okay, this is the time to do this. So Let's talk about why healthy soils are important for climate change mitigation and adaptation. What is it that they're providing when we're talking about climate change? So let's first talk about the 5 healthy soil functions. So with carbon as the cornerstone of that. So the first one we think about with climate change, right, is that soils hold carbon. So they store SOC, and then they capture it from the plants. So let's look at what else that does. So once you have carbon in the soil, that's when you can start having water storage and filtration happening. So when you have carbon in the soil, carbon is a really complex molecule with a lot of surface area, and it starts to hold on to water and also nutrients. So when it holds on to the nutrients, it filters it out of the water. So when you have water moving through your soils, it's operating as a sponge that's grabbing all those nutrients and also holding onto that water. That water is what allows us to deal with the effects of climate change, right? You have a prolonged drought, it's going to have the storage in the soil in order to be able to maintain its health. And on the flip side, you have a whole bunch of rain coming down, right? Because we have these sudden large storms that are happening. That's a sponge that's able to hold that and prevent it from spiking all of our spiky hydrographs in our streams, right? Which we don't want. So we want to be able to hold on to the water that way as well. So when we are operating as a filter, that means it's holding all those nutrients in the soil and they're not washing through. So if you have just sandy soils and you throw a bunch of fertilizer on it, most of that water is going to go straight through and into those nutrients are going to go straight through into your water systems, right? Which is where you do not want them. So the carbon in the soil is really what's holding on to those nutrients as well, and then allowing, once again, for the plants to be able to adapt and hold on when there's changing conditions, right? Because they have the resources that they need. And so with those 2 resources, water and nutrients, we are able to have productive capacity. So all of a sudden now we have the resources we need to grow a lot of plants. And that's what we think healthy soils, you're talking about your lawn or ag, this is what most people mostly think of, right? They think of this is what a healthy soil is, it can grow plants. So that is one of the functions. And that function, the ability to grow life, plants, also cascades down through the system, right? You have your secondary consumers who are eating the plants, you have your bacteria and your fungi, and then your tertiary consumers, right? Who are eating the things that eat plants, right? We know all about this, the ecosystem. So the plants are the linchpin of that ecosystem, right? So those are your 5 functions of soil. I'm sure there's other ones, but those are the primary ones that we identified. And it's that productive capacity that then is pulling carbon from the atmosphere and putting it back into the soil, right? So there's this feedback loop that's happening where we're able to reinforce all these positive things if we can get the ball rolling and we're not destroying that. So I was just talking about soil function, ideal soil function, right? Which, if we were going to design soils, they would kind of all be the same. They have high carbon, they'd be kind of well draining, but we live in a diverse world and we want a diverse world. So we should not only assume that a beach dune is not a viable thing to have. So we should also, as a kind of aside here, not just be focused on high functioning soils, we should also be thinking about what are the geodiversity that's underpinning biodiversity. So this is just an aside, so we're not just focused on performance. Okay, so where is the soil carbon? Here's a diagram from the IPCC that looks about where the carbon is stored across the world. And we can see that wetlands are really, Sarah's going to be talking about wetlands. These are the thing, right? They're holding all the carbon underground. And if we look at temperate forests here, we can see that they're holding quite a bit. And you'll see that they're holding more in the soils than above ground. We think of forests of having a lot of carbon, and they do. And we do what we can see, right? So it's the trunks, the trees, the brush, but really a lot of that is underground. So when we looked at the Massachusetts land cover here, we can see that Massachusetts is primarily forest. So if we add it all kind of up, and depending how you clump it, we end up with 62% forests, and 12% wetland. So as part of the Healthy Soils Action Plan, we modeled where all the carbon was and mapped it. So you can see things. So there's certain things you can see here. The darker the color, the more carbon. And we can see like the coastal wetlands, right? And I think Sarah's going to show you some of these pictures. Like on the Cape, you see that one on the Cape there? Or that big dark spot? Sarah's going to show you a zoomed in picture of that. So the wetlands are really, you can really see that. The upper Quabbin area, you can see there's a lot of like wetland soils up there. People have been up there. There's a lot of stuff there. You know, lower down where all the cranberry bogs are there in Massachusetts, that's where there's a lot of it. The Berkshires is an interesting one because they have more limestone-based soils, so you end up with kind of more carbon in there in different forms. So if we look at the different land cover types, this is the average SOC per acre in metric tons. So metric tons per acre, we can see that wetlands have 321 metric tons per acre on average. Forests have 87. I think it's actually a little higher than that, but in this it's 87. And then if we look at agriculture or turf lands, it's about half that. So there's, on the same exact soils, if you have a forest there that's been there a long time, and a agriculture or turf, you're going to lose half of your carbon. So we kind of calculated the total amount being 396 million metric tons of carbon in the soils in Massachusetts. If we look at, on the left side here we have acres, on the right side we have SOC stocks. Okay, I should get moving. So I just want to show you that 12% of the acres are in wetlands, 50% of the carbon is in wetlands. The acres that are, you can see there's twice as much turf as there is agricultural land in Massachusetts. So every lawn is valuable. If we can increase the SOC that's stored in that lawn, these are our managed landscapes. This is really where we have a big impact, right? So let's keep moving. Okay, so what impacts soil carbon? Land conversion. So if you convert it from a forest to something else, it's going to lose a lot of carbon. Management, how you manage it makes a big difference, and then climate change. The two things that are the factors of residency, how long soil carbon stays in the two like most basic physics things of why it stays in the soil is temperature. Right? You increase temperature, you increase biological activity, you increase your pumping out of carbon from the soil, and moisture. The wetter the soil, the more it stays in there and retards the aerobic bacterial breathing. Decomposition. There you go. Respiration. There. Okay. We think of soil being created over time, right? We can think of disturbance as reversing that arrow. As in simplistic model, we can think of it as bedrock gets moved into soil, disturbance reverses that. Disturbance does the same thing. If you think about agriculture, the difference between a perennial undisturbed agriculture where you have forests versus a annually tilled, right? You're doing constant disturbance in there. You're reversing that time. You're introducing lots of oxygen that is going to be pumping the carbon out of that soil. So, the less disturbance you can do, the better off you are. So, construction soils also have a pattern of disturbance, right? This is a very disturbed soil. You're churning up all that soil. You're introducing the oxygen to the soil piles, and it's being respirated off. So the more you churn it up, the worse it is. If we looked at two different sites, so in site A, we ended up there in the middle picture at the top with it 2¼ acres being completely cleared, and we did our best to return it to a beautiful meadow. In site B, we got there when it was pure forest, and we were able to annoy the contractors a lot and get them to only build right around the building there. So if we looked at the carbon impact, let's imagine this is an ideal scenario. This is the carbon on that 2¼ acres. So we can see that we have 191 metric tons in the soil and 125 above ground. If we just left it for 30 years, we would expect 56 metric tons of sequestration to happen. On the first one where we cleared it, after 30 years we would expect 8 metric tons above ground and 74 metric tons below ground. And if we did only a half acre of clearing, 91 metric tons, 160 metric tons, which means that on the top one, we lost 290 metric tons to removal at that time and lost sequestration potential. And 121 metric tons in the better one. So that means that there's a difference of 160 metric tons of carbon, which is a significant amount of carbon. All right, so I'm just going to go through these real quick. So here's the kind of business as usual. If we did business as usual construction, and this is where land trusts really have an opportunity, right? Preventing development in existing forests and farmlands, right? We would expect to lose 25 million metric tons of CO2. I was at the NESI conference yesterday, and there was a presentation about storing carbon in houses, doing the most amazing houses you can do, straw bale construction. You're storing all this carbon, you're not using all this carbon, and they were looking at across the U.S. They were hoping to do 100 million metric tons of saving it through all the construction projects that they could think of. So just in Massachusetts alone, they were talking about potentially losing 25 million due to construction. And there's a bunch of better practices that we can talk about. So protect and conserve, the first one, better practices in construction process is going to have a huge difference. Using more regenerative and perennial-based agricultural practices is going to have a big difference. And every square meter of soil matters in an urban context. The higher performing you can have of the soils, the more functions you can have that can balance out all the urban areas. So right now we are currently working on this guidance for implementing healthy soils in landscape and construction. If you are interested in this, please get involved. We have a website where we have the masshealthysoils.org. We currently have proposals out to do this for agriculture and wetlands, where we're doing best management practice for both of those. So please check it out. Thank you.
All right, so now we're moving on to those superstar wetlands that were mentioned. So my name is Sara Grady. I'm the senior coastal ecologist with the Ecological Restoration Program at Mass Audubon. And Mass Audubon has our guiding action agenda goals, and restoration is very important to Mass Audubon because a restored landscape is more resilient, it's more welcoming, and it is more prepared for climate change. So why wetlands? We had a quick hint of why wetlands are so important, but the low oxygen in wetland soil, especially peat wetlands, reduces decomposition. And so these wetlands are able to accumulate and store carbon. And just like you would maybe turn over your compost pile to increase decomposition, you do not want to oxygenate all of that peatland too much. So Massachusetts, in its clean energy and climate plan, called for no net loss of stored carbon by 2030. And a big part of that is through protecting open space, including wetlands, facilitating marsh migration, and facilitating restoration, which includes the very important issue of streamlining permitting for restoration. And if you haven't seen the Mass Audubon table, you can sign up to help support some of those legislative fixes. So I'm going to start with cranberry bogs and the natural peatlands. Many cranberry bogs are former natural peatlands that have become agriculturally degraded. And for both salt marsh peat and for freshwater peat, the carbon content is very dependent on peat depth. So I want you to kind of think about, the deeper the peat, the more carbon we have stored away. And the more carbon storage is created when you're able to restore wetlands. So this is just a graph from a study of various peatlands in Canada. And you can see that bogs and fens, which are very peat-rich wetlands, you have much higher soil organic carbon. And I also want you to just take a quick note of the depth of those different peat thicknesses, coming in around 200 to 300 centimeters deep. So I'm going to talk about Tidmarsh, which is now Tidmarsh Wildlife Sanctuary, formerly Tidmarsh Farms, down in Plymouth, Massachusetts. It's the largest freshwater restoration in the Northeast, over 200 acres. And in some places, the peat was 30 feet deep. So that's 900 centimeters deep below the cranberry bog sand. Cranberry bogs are ditched to move the water efficiently across the surface of the bog, and that increases decomposition. So again, that oxygen getting down in the peat is a problem. You want to fix that. And also, these bogs are on a drying trajectory. They're former wetlands that need to be wet in order to do what they need to do. So this is what one of these bogs looks like. This was before restoration. You can see it's flat, and the sort of pinkish reddish color is all those cranberry vines. And then you get in there and you can get down to the groundwater and get that wetland functioning again, getting that carbon pulled down into the peat again, and you get something absolutely lovely like this at the end, where you've got all of those great diverse plants that are doing their job, pumping that water down, pumping that carbon down into the peat. So I am a coastal ecologist, so many of the cranberry bogs that I'm working on are coastal cranberry bogs. I mean, most of them in southeastern Mass are, I suppose, technically coastal, but importantly, they are connected to our coastal wetlands in the future through sea level rise. And there's a term used to refer to our marine peatland carbon, and as well as our mangrove and seagrass carbon, which is blue carbon. A very trendy term to some degree, but all that matters is this coastal carbon. These coastal habitats are able to sequester quite a lot of carbon. According to the EPA Blue Carbon Report from 2023, there was a study of wetlands from Maine to Long Island. It was eelgrass meadows and salt marsh. And there are over 200,000 acres of eelgrass meadows and salt marsh that are holding the equivalent of the emissions from almost 6 million passenger vehicles or 30 billion pounds of coal. I mean, these numbers are huge, right? Lots of emissions, and the quantity of carbon that's accumulated in 1 year in about 32 million acres of forest. So if you kind of do an acre to acre comparison, you've got the amount of carbon in 1 acre of these blue carbon habitats is equivalent to 150 acres of forest and the amount of carbon that forest is taking in. In New England, our sequestered carbon is mostly in salt marsh. We do have eelgrass meadows, but so much of it is in salt marsh. So if you look at the carbon that is in our salt marshes, we are, again, superstars here in Massachusetts because we also have a lot of acreage of salt marsh. So we have a lot of marsh, and we have pretty deep marsh as well, which gives us a lot of carbon stock and a lot of carbon sequestration. These carbon stocks are based on the assumption that the peat in the marsh is about 1 meter deep. However, we're learning that depending on the shape of the salt marsh, so is it behind a barrier beach, or is it a former embayment, or is it a drowned river valley? These are all geomorphological ways to describe the shape of the salt marsh. We have peat depths, that's the 1 meter depth. Our marshes are deep, they're thick. So we have a lot of marsh, and we have very thick marsh, and that is a lot of carbon stored away. And so what does that look like? Well, so this data you can poke around yourself on the Northeast Ocean data portal and look and zoom in on your favorite estuary. But there is a lot of carbon that is stored away in our marshes. And if you look at Barnstable Great Marsh, which was the one that was previously mentioned on the north side of the arm of the Cape, you can see that as you get closer to the upland, you're getting those deeper peat depths and you're getting more dense carbon as well. So what do I do? Well, I'm a restoration person in our ecological restoration program. And so some of these, many of these, possibly all of these salt marshes are starting to degrade. And that is a place where that carbon is going to be lost. So we have this giant treasure chest full of carbon that we're seeing get stolen from. So here are the pieces of our toolbox that we use to try to fix that problem. So salt marshes need salinity and they need sediment. And that comes from tidal flooding, those twice-a-day tides. However, too much flooding can drown them. So we get these marsh pools, and so the restoration technique that's used is something called runneling. It's a narrow or shallow surface channel that allows those pools to drain and revegetate. So our salt marshes need to drain, but over-draining, or think about the ditches and the cranberry bogs, can lead to oxidation and subsidence. So we do that, we fix that by filling in those ditches with the grasses on the surface of the marsh and leveraging the power of marsh grasses to collect sediment that's in the water column. Our salt marshes need sediment. There are some places that we might actually have to start adding some sediment. I like calling it marsh nourishment because it gets us into the same vocabulary as talking about beach nourishment, maybe something that requires a little bit more maintenance versus a one and done kind of project. And finally, our salt marshes are getting squeezed. Sea level rise from one side, coastal development from the other. So the solution is to look for marsh migration corridors, whether those are upstream freshwater wetlands or coastal open space that can transform into marsh habitat. Things like parking lots that are going to get flooded in 30, 50 years. You might consider, okay, we're going to do a managed retreat. We're going to have that place return to being a marsh. So what can you do? This is the take-home message from our wetland side. You can protect wetlands from excess nutrients, which leads to decomposition. So that's a watershed-based management. Protect wetlands so you can restore them if needed. Protect those marsh migration corridors. So look upstream of the salt marshes and look at where they might be going. Support those regulatory changes to make the pace of protection and restoration faster because we're on a ticking clock here. And our existing regulations currently treat restoration like development. We have a wonderful Wetlands Protection Act in Massachusetts, but it's kind of tripping the restoration community up a bit in terms of pace. And finally, use your outside voice, promote the importance of wetlands as a climate solution.
Okay, I'm still loyal to forests, but wetlands are super cool. And I know Bosch talked about the Healthy Soils Action Plan being held up. I will say that it is the second, I've been in this field for 20 years, is the second best stakeholder process I've ever been a part of was writing that report. It's super cool. And I probably should have mentioned at the beginning that we have resources up on the conference website. So there's actually like a PDF that has a lot of the things we've talked about. You can read more about the awesomeness of blue carbon systems. You can read the Healthy Soils Action report as well. I'm pretty sure we put it on there. Yeah. So one more case study. 10 minutes, then we move into plenty of time for questions and discussions. So my case study is about climate smart forestry, and I decided to use Tim Stout to tell this story. Tim actually doesn't live in Massachusetts. Tim is a landowner in Vermont, just a little north of us. He has 173 acres of forest, and like happens to most people, when his grandchildren were born, he started getting a little philosophical and started really thinking about the legacy that he wanted to leave with his land, what he wanted his grandchildren to be able to enjoy and someday inherit. And this, Tim is also someone who's always been really interested in learning about forestry and how he can do different forestry techniques on his land. So in about 2020, the stars aligned, and Tim came south to a series of stakeholder workshops that we had, including with some of you in this room, or at least your organizations. At the time, in 2020, we were trying to think about what climate smart forestry looks like in Massachusetts and Vermont. And I don't want to imply that nobody knew what climate smart forestry was. It's very well defined in the literature. Climate smart forestry does three things. It either maintains or increases the amount of carbon stored in the forest. It maintains or increases the resilience of the forest, its ability to deal with climate change impacts. And it treats all of the people involved in the process equitably and fairly. Again, often coming to things that we don't think about, like just how crazy risky a job harvesting timber is and what can be done to help make it a little bit safer. So out of that workshop that Tim and many others attended, we came up with a number of practical climate smart forestry techniques that could be done on the ground here. You can find these with your favorite organization. You will see almost the same list in all the things on this screen. Down in the bottom is the Healthy Forest for Our Future guide. That's the workshops that I led that Tim was at with expert facilitation from the U.S. Forest Service NIAX team. So that's a TNC and U.S. Forest Service publication. Just to the right, you see DCR's Caring for Our Woods publication about carbon. Moving over, you see New England Forestry Foundation's Exemplary Forestry Standards. And in the bottom right, you see one of my favorite landowner outreach materials ever, Mass Audubon's Foresters for the Birds booklets, which are beautiful as well as practical. And the idea of climate smart forestry and why it was so important to do is we were really focused on carbon, right? So climate smart forestry, no matter what form it takes, basically stores more carbon than business as usual. And in this part of the country, that often looks like the bottom part of this graph. Someone might own a forest. Maybe they do a cut that's really designed to maximize short-term income. So they might cut too heavily. And none of this is generally done as I'm going to wreck the forest. It's more just circumstantial, right? Somebody offers somebody a lot of money and they don't have the time to research it, or they don't have access to resources. And so what often happens, we see this a lot, particularly north of us in Maine, you get a really heavy cut. You come back 10 years later, the forest has not fully recovered, so you can take out a little less wood, and you keep doing that a bunch of times, and pretty soon you're in a situation where you can't produce a lot of valuable wood products. You may have reduced the biodiversity in the forest as well, and all sorts of other impacts. And if you're a landowner at the end of that stage and you need to get income out of your land, you're also a little stuck because so much of it was taken out early. At the top, you see climate smart forestry, which might look like things like spreading out the time between harvests. You could be taking off less wood in that first harvest, and then growing it more into larger size classes. Different wood products come off of there at the end. But I want to note that while climate smart forestry runs the gamut from forest reserves, where you are not generating any wood at all, to all the way where you are producing a lot of wood products. I think often people think about carbon and wood as just you can't have both. And certainly there are trade-offs involved, but you can manage forests in ways that produce wood as well as storing more carbon into the future. On the right side, I have the DCR Walden Pond Visitor Center, and I just get such a kick out of giving this talk here because I don't know about you, but this concrete bunker we're in does not spark joy for me. It just doesn't. And we've got a little bit of wood paneling on the doors, right? But when you are in a beautiful wood building or your house, which is probably made of wood, it feels different. In addition to all the carbon and other benefits of using wood, it's actually a really great material just psychologically as well. I have not gotten to go to the Walden Pond Visitor Center, but they made every attempt to put as much local wood into there as possible. Massachusetts is a great place to produce wood because we have really strong environmental protections, a really educated group of land stewards, mostly private ownership. So it's a great place to do these things. To get back to Tim, who's waiting somewhere on that slide, Tim Stout also wanted to do one of these climate smart forestry techniques that balanced production of wood as well as growing carbon into the future. He has some great photos and videos online, but none of them to me really got across the story of what he did, which is basically he did a harvest on his land. He has some areas where he wanted to do maple sugar collection. And it wasn't in the best shape for that. So he did some thinning around those sugar maples, tried to kind of get it more in a condition where he could produce more maple syrup more reliably. And this is not a picture of his forest. This is the Tug Hill Preserve owned by the Nature Conservancy in New York. But both Tim Stout and Tug Hill basically did a type of climate smart forestry where they did thinning or gap creation, but did it a little bit differently in ways that store and sequester more carbon over time. So in these gaps at Tug Hill, one thing you probably can't tell is scale, but these are about 1 to 1.5 acre gaps. So they're roughly trying to mimic the type of disturbance that you would see quite frequently in this forest. If you look within them, you can see some of these really large trees were left for seed source and biodiversity and all sorts of other good reasons, including carbon. You can see some standing dead trees or snags, which were also there, and you can see a lot of downed wood on the ground. Similar when Tim Stout was doing his thinning, if you zoomed out, you would see that he was doing thinning around these sugar maples, but overall across his woods, he was taking out less wood than he would sort of as business as usual. And all of this forestry was done in a way that these forests after 20 years would have recovered all that carbon that was taken off and put into the wood product stream and more. So I'm going to go to the next slide in a moment, but I just want to tie it together with the multiple calls to action that we've made to you so far. First, as Sara emphasized again, use your outside voice. If you work on natural climate solutions, talk to people about it. Secondly, one of the things I really like about the work that Bosch talked about is that often in the land trust world, when we're not able to prevent development, we sort of wash our hands of it and we view it as failure. As opposed to thinking about all the ways that low impact development or differences in the way you clear land or move around soil might be able, as he showed, to avoid some of that carbon loss. And then Sara talked about permitting. Super important and super boring, but really important. So please do go visit the Mass Audubon table. Many of you are probably involved in the discussions happening right now, trying to make sure that we're not putting up unnecessary barriers to people who are trying to restore wetlands and make sure that all that carbon down in the bottom is not lost and released. And finally, if you work with forest landowners or you are a forest landowner, there is still a lot of money out there and technical assistance to help landowners choose climate smart forestry practices. And I've just put a couple on here with their contact information. This is by no means an exhaustive list, but I just want to point out that DCR still has their climate stewardship incentive program, though a little bit lower funding than has been in the past. NRCS is sometimes still working with landowners. The Family Forest Carbon Program is the Nature Conservancy and American Forest Foundation program that Tim Stout enrolled in, which uses carbon offset markets to pay landowners annually for choosing climate-smart forestry. If that's not your cup of tea, there are other climate offset programs out there, including Forest Carbon Works. New England Forestry Foundation just launched a program for landowners who have oak hickory forests, especially ones that maybe aren't in great shape in terms of oak and are really interested in regenerating that species. If you are a town, there's the Municipal Vulnerability Preparedness Program. I cannot emphasize enough how many people are happy to work with landowners to try to get them help in thinking about how to balance carbon along with all the other things that they want from their forest land. So with that, I'm going to remind everyone that we are being recorded. We have a lot of time for Q&A, and if there are questions that you don't feel comfortable asking on camera, which is totally understandable, my co-presenters and I will end things a little bit early and then just hang out in the room so that if you have something you want to ask us separately, you can. But I want to thank again Bosch and Sara for presenting and all of you for listening through all of this. And we're happy to talk with you about any of the case studies or topics that we talked about today. Oh, that's okay. I think we're going to have to stay
right,
there,
yeah.
That's
so
true.
we'll
We'll
just
stand around.
shuffle.
Let me know what I'm drinking, cranberry juice. So.
Oh, nice. Very comically appropriate. Nice prop. Any questions for any of us?
What are some of the benefits and drawbacks of, just leaving a forest as is versus implementing those, forestry practices you were talking about?
Yeah, I'm going to give the standpoint of my organization, which isn't to say that's the answer to your question. It's just I work for the Nature Conservancy. We think a lot about this in the context of Massachusetts. So we think about things spatially a lot. So in our overarching plan for Massachusetts forests, if we could snap our fingers and have our way, we'd probably have about 10% of the forests in forest reserves that are not managed commercially, and about 90% of them managed for a mix of values, including timber harvesting. The benefits depend, right? What condition is the forest in? Are you in a restoration case? We own some forests that we have left alone for 40 years, and they're lovely, but they have not recovered the way we wanted them to. Given enough time, they would, but it's going to take a lot of time. Are you in a super healthy forest that's growing like mad, that's really biodiverse, that's doing great, right? So the answer is very dependent. But to me, I take a lot of comfort in the idea that we need things at all points along the spectrum. And when people say, what can we do to maximize carbon? I often have trouble with that question, because to me, it would be siting things along that spectrum in the places where you're going to get the most benefit from each. The other thing to think about is that as you probably know, Massachusetts imports almost all of its wood products. There's a huge carbon footprint there. So it also depends on how far out do you want to look as you think about that question. So I know that's not a perfect example. The one thing I would say is I hear a lot of landowners asking that question, and then they're given something that is hopelessly complex. And I really come back to right here at UMass Amherst, Paul Catanzaro is a real fan of being don't be paralyzed by that, right? Think about it, but then go forward and don't worry that you maybe haven't optimized every single acre that you own. Just, be an informed landowner, but don't get so hung up on it, because forests are quite resilient here. And there are very few things that I think I've seen landowners do where it's just not going to recover. So yeah, I don't know if that helps.
I should be calling someone.
Should be a comment.
In terrestrial environments, is it true that it's the roots of trees and grasses that are probably going to be the permanent soil carbon, and not the branches and the leaves and those sort of things? They're less likely to become long-term soil carbon.
You want to take
So I don't know that answer. So I think that probably makes sense. Restate the question. Yes. What part of the plant becomes a long-term storage carbon? I didn't include that slide. We do have a slide where we talk a lot about those kind of things. I think it depends. Like, let's say you have leaves that fall, right? And you have earthworms, right? They're gonna like, have you ever go outside on some spring night and listen? You'll hear the earthworms going, and they have these little like hairs, and they pull the leaves and they pull them down under the soil, right? And so that's the kind of thing that once it's in there, they're gonna do their best to like start the process, right? And some of that's going to be converted into soil carbon over time. The branches and the leaves, I think that's going to decompose, become that O layer that then will slowly pile up and go down, right? And become your A layer. So I don't think that's necessarily true that it's only the stuff underneath.
Is there a scale issue? So we own land at our land trust from 1 acre forest to hundreds of acres of forest. And sometimes we get paralyzed, like where do you start? How do you address these hundreds of different parcels we have that are all scattered around? Different towns, different parts of the state.
Do you want
No,
me to-
you go ahead.
Okay. Do you have any
It
wetlands?
sounded like a forest question.
And these are mostly forested parcels, or they range?
Forested wetlands.
Okay,
Uplands.
yeah.
We have kind of a full portfolio.
Yeah, so there's a couple things, and I get this a lot with landowners. Often when they call and they're like, I know it's really bad, but I haven't done anything with my forest for 15 years. And I'm like, okay, that's great, right? Like, there is this sense of I must do more. I have to find out the perfect answer. You as a land trust have presumably protected that land and are stewarding it. You're watching for things that are going wrong every single year. That is a big lift in and of itself. So I guess my first thing would be, especially for some of the smaller parcels, I would be thinking more about whether anyone in the community had brought something to my attention, or you see something, like you've got an invasive that's creeping up there that, is just taking off like mad. Like, I think especially the stewardship staff or volunteers or whoever that is for your land trust are often the first to kind of see something and say, you know what, I think we need to do something here. So that would be my first thing, is just sort of like trust in whether that's you or that's someone else who's out there all the time, or even people in the community who are using it who might be bringing things to you. I think the biggest thing is just avoid maladaptive actions. Often someone might be in a position like you, and then they have an invasive pest like emerald ash borer come in or something, and they're like, we just got to cut everything right away. Like, try not to do those like knee-jerk reactions. But I will say, again, coming from the standpoint of an organization that watches very carefully, including Julia's in the back, who goes out on many of our lands every year, and she would alert us if there was something that we needed to act on. There are many years when on many of our preserves, we don't feel the need to do anything particularly active about them besides maintain the trails, watch the boundaries, watch for things that are coming in, treat the invasives that we know are there. So that's that's sort of my overall answer. The other thing, and I just gave a talk for Land Trust on this topic, is tie it back to your mission. So many land trusts, like there aren't a whole lot of land trusts that just have as their mission, like we just protect land, right? It might be, we protect land for the enjoyment of the people in such and such town in these ways, or because we want to balance the production of food. And, like if there's a piece of your mission that you can tie to that, then I think you're going to feel really good about finding those actions that you can take. But from a carbon standpoint, these things are sequestering carbon whether you do something or not every year. So I don't think you need to worry about that. I would watch those things that either threaten that or threaten your mission or threaten the use. Did you want to say anything about the wetland piece?
Yeah, I just thought, so you're talking about, they're going to keep doing what they're doing regardless. But if it's a coastal wetland, I would say, you have a little bit of a more urgent need to make sure that the wetland is maintaining all of its function or close to as much of its function as possible. The threshold at which a wetland needs attention in terms of acreage on the coast is much lower. It's fabulous if you happen to have some huge cranberry bog, or you happen to have frontage on a massive salt marsh. But there are a lot of little pocket wetlands. One thing that I really am hoping to promote more going forward are a lot of these fringing wetlands, many of which are in urban communities, and people kind of are like, oh, well, that's just the marsh that's along the river. But when you add up that linear area, it actually becomes quite a lot of important wetland in a place that doesn't get as much attention.
That's great. In the back, yeah.
I'm from Cape Cod, and we have a lot of bogs and a lot of coastal wetlands. But we wouldn't typically, as a land trust, think about buying land that's wet because it's not going to be developed. So, but it seems like what you're suggesting might be that maybe we should be thinking about that. And I'm wondering if that's true, and if you have a sense of what the ownership is. My town is Barnstable. We have the Great Marsh there, and I think that the ownership is pretty split up of the wetlands. So I'm just wondering if there's an acquisition solution that you would recommend.
Yeah, so you're right, there's a lot of private ownership on some of the wetlands on the Cape and the coast in general. Barnstable, Great Marsh in particular, is a pretty good mix of land trust and state land and town land. And not every part of the marsh needs restoration or protection as urgently. And that's something that I'm working to try to synthesize right now. So we're hoping, Mass Audubon, are hoping to come out with some additional guidance soon that really highlights the places that are important to focus on for wetland protection and restoration on the coast. And inherent to that process is also going to be looking at ownership, because ownership can be it's a factor in working on those lands. I will say that we have been contacted by a few private landowners in the past that say, hey, I live on this marsh, and I noticed it's starting to fall apart. What can you do? So I think there is room for that private partnership there too. But I think changing the thought process as far as, oh, well, it's just a wetland, no one's going to develop it, is important because of the function of those wetlands.
I would say the wetlands are protected from development,
Yeah.
right?
Yeah.
That's the thing, right?
Yeah.
They're not protected from the impacts of other activities around them, right? So I think that's the difference. And I think you're thinking about migration as well, right? Because what are the pieces of property that are going to allow, we have this problem where you have the sandwich that Sara talked about, right? The sea's coming up, the development's not going anywhere, right? So in a natural system, in an undeveloped area where the sea level is rising, the marshes would be able to move back into the other places, right? But we have a seawall there or a house, right? So it can't do that. So where are the places that you can think about where you could do some migration or preemptively remove some soil to create that same space?
Yeah.
Can I just say something in response to that question? So I live in the coastal New Hampshire area, and in my neighborhood, and this is one of the reasons why I'm here, I've been watching the development happening in my neighborhood, which my home abuts a piece of land that has 5 vernal pools and a lot of wetlands. And I'm trying to figure out how to help neighbors that are moving in be really aware of their impact on that, because the city is trying to manage the wetlands buffer zone and the wetlands area, and if they are not aware of what happens, then our neighbors are taking down a lot of trees. And I think anything that can also help with education of landowners and ongoing education, knowing that like new neighbors come in and out, I'll request that because it's something I know that affects us pretty significantly.
And on that education of landowners front, especially with salt marshes, nutrients are a huge impact to marshes. They cause the below ground biomass, those roots and rhizomes, to degrade faster, which causes the marsh surface to sink, which with sea level rise just creates a bigger gap that marsh has to try to accumulate sediment to keep up with. So if there's anything anybody can do, people are, oh, well, I'm not a restoration ecologist, I'm not a land owner. Just like tell people not to put fertilizer all over their lawns, extra fertilizer that's gonna go down into the marsh.
Can any or all of you comment on the role of invasive control in climate-based solutions for climate resiliency, climate change?
Yeah. I'll start with
yeah.
that. One tricky place that we encounter invasives for coastal wetlands is in Phragmites. And there's always a question about Phragmites removal. Should you try to get rid of all of it? And we're still, there's no actual official position, I would say, but it's pretty good at sequestering carbon in some places on the upper part of the marsh. But where it is an impediment to marsh migration, so if it's in a corridor, a hydrologic corridor, that's a great place to focus on removing it.
So do you want to say anything about it?
No, that's not my area of expertise, I'll say that.
I'm going to give you a general answer and then a specific example thinking about forests here. The general answer is I draw a distinction between invasive plants and invasive pests and pathogens. So invasive pests and pathogens that have the potential to come in and kill an enormous amount of trees relatively quickly, to me is very relevant from a carbon standpoint. And some of the solutions are deceptively easy. Don't move firewood, early detection and control. When it gets to invasive plants, we thought really hard about that in our climate smart forestry workshops. Under what circumstances might invasive plants be something that would meet all those principles, right? It's having a measurable impact on carbon. I can demonstrate that when I remove them, there are carbon gains that are sustained, right? This is a really, really high bar. And I will tell you that the stakeholders who were at our groups, from foresters to loggers to county foresters, service foresters, land trusts, we really honed in on bittersweet and other non-native vines that almost act like those pests and pathogens, where there are some places where they are so abundant that they are killing the trees. That was the one spot where everybody agreed they felt like there was a carbon impact. When we got away from that, again, you've probably, when you have a bunch of experts in a room, sometimes they're like, yes. And then sometimes they're like, well, under this circumstance and this circumstance. And like, that's what happened when we got into the invasive plants. We did, so if you're interested in the Healthy Forest for Our Future guide, we did actually list out a % cover threshold for invasive plants, which was sort of everybody sort of agreed, above that, I think you're gonna get regeneration problems with native species, so you might wanna do something. It's not an answer for you, but it's a piece of it. If I was looking at a forest and I had 5% invasive cover, I'd be inclined to think that maybe strictly from a carbon standpoint, not talking about other things, removing those might be questionable in terms of a strategy. If I had 80% vine loading, then again, it would be the opposite. I'd feel like, yeah, treating that, I think probably has a carbon impact. So maybe that's a little bit helpful.
Where do you find that list again?
Sorry, so it's on the resource guide that is on the conference site, but it's the Healthy Forests for Our Future guide. Once again, I'm looking at Mass Audubon and Neff and other people, many of the same things are in various publications, but that would be a place to get that. You're also gonna find some similar ideas in what Mass Audubon and DCR and Neff and others are putting out.